Hello and good morning. Thank you so much for joining us here on KXAN Plus. As you could see from our little intro, we have our Kristen's Classroom segment. And it seems like it's going to be a fun one. And I'm here with meteorologist Kristen Currie. Kristen, thanks for joining me. How are you doing?
Of course, doing pretty good. Getting ready for some cooler weather, some rainier weather. So we're excited about that.
Yeah, we're excited for the possibility of rain chances later this week. So this week seems to be going pretty good for me. How about you?
Yeah, we keep our fingers crossed that everything stays on track, right? We
Yes.
always joke like whisper when you say rain chance, right? Don't spook it, don't scare it. Right now, we're pretty confident in seeing some rain on Friday night.
That's awesome. Well, I'm excited to hear about your school visits this week. And I'm also excited about this topic because you have some stuff in here in the studio that we're going to use. So I know it's going to be really fun.
Yeah, it kind of piggybacks off of something we talked about last week, and that was the fact that there are multiple ways that we measure weather down here at the surface, the clouds, up top of the clouds, and space. And so I kind of wanted to do like Weather Tools 101 today about what we do, how we measure weather, and where we put that data once we do get it. So let's launch into it because when it comes to this first
Tool.
this first tool.
We had a sneak peek last week about some of the tools, but I'm excited to see them here in person.
Yeah, absolutely. The first one is something that you've probably passed or you've seen it before and don't quite realize what it is. These weather stations that we have down here at the surface, there's a greater system, a greater program that we have here in the United States called the Automated Surface Observation System. And basically, you're looking at one of those. These normally live at the airports or military bases.
They look funky.
Yeah, they look real funky, right? The ones we use to record the data with the official records are located at Camp Mabry and Austin Bergstrom International Airport. But this contraption here measures visibility, sky conditions like fog and haze, current weather, so whether it's snowing or rainy or sunny, temperatures, dew points, and the actual measure of moisture. So you could think of that as humidity, wind speed and direction and gusts, and then precipitation, the amount of precipitation and pressure. So that whole contraption there is measuring all those different things. These live, like I said, typically at the airports or military bases, and they collect measurements every 1 minute and record them. You can find this data online. The Weather Service is pretty much in charge of not only looking at these measurements and making sure the equipment is correct and operating okay, but there's also the Federal Aviation Administration is involved in this in addition to the Department of Defense. But I like to go to school sometimes and show a very simplified version of this weather station. So obviously this looks a little simpler than what I was just showing you, but it does the same kind of thing. That's the fact that every little piece on here is giving us a different tool to measure the weather. So this would be my wind vane. This is always going to point in the direction the wind is coming from. And that can sometimes be tricky because people, they flip flop it. Sometimes they'll call a wind where it's blowing to, it's where it's blowing from. So this is going to point in the direction the wind is blowing from. We've got obviously the thermometer right here. That's going to tell me what the temperature is. And then my anemometer measures wind speed. So this would be wind direction, wind speed, temperature, and then I've got a little compass here on the bottom that would show me the wind direction there. So this would be my simplified weather station. These, again, don't move. They stay right down here at the surface. This is a very simplified look at it. In reality, if we go back to the graphics here, these weather stations kind of work in two parts because the temperature, the dew point, and even sometimes the pressure, that's measured about 5 feet off the surface. The winds can sometimes, though, be measured 30 feet off the surface. And
Wow.
they do that because they don't want any interference from trees or from buildings nearby. So when it comes to measuring wind, it would be about 30 feet on the tower, and then about 5 feet with the temperature and the dew point. So down here at the surface, weather stations, or if you ever hear us say ASOS, the Automated Surface Observation System, that's what we're referring to. These weather weather stations here that stay right at the ground, and the weather just moves around it, in it, over it. And that's how we get the data from here at the surface.
And Kristen, the little instrument that you brought into the studio, is that the exact same size as a normal instrument would be out wherever it's measuring the
Not
weather?
at all. No,
No?
this is a very small kind of kiddie version, if you will.
Yeah.
But it makes it easy for the kids to understand. And so I'll ask them, if this is moving super slow, is this a really fast wind or is it a really slow wind? And they would tell me it's a little bit of a breeze. I'm like, if this is moving super fast, does that tell me the wind is strong or light? And so I'll use that here. There used to be a little rain gauge that sat
In the middle?
right here. Lord knows where that went because I've taken this to so many schools. But there is a rain gauge attached to it. But in the one that I showed you, the real life version, you'll notice there's some coverings on it because they don't want any sort of contamination of the data. So oftentimes they'll cover the thermometer because they don't want it in direct sunlight. If you're in direct sunlight, obviously you're going to get the temperature reading a little higher. We're looking at ambient. We want the ambient air temperature, not what it is right in the direct sunshine. Yeah. What is the air mass temperature? And so there's a little covering on there for the thermometer, in addition to there sometimes with the precipitation, they'll put
Rain gauge?
Yeah. Not necessarily a cover on it, but there's a little bit of a buffer so they can measure it correctly.
Nice. And how often does something like this need to be replaced?
They can go for years. It depends a lot of the times on what the weather is. Sometimes if you get a really strong thunderstorm or a hurricane, they can knock these out pretty quickly. But I would say they're sturdy enough to withstand the normal day-to-day weather. Like I said, we've got 2 of those here in Austin that we record and observe and use almost daily. The temperature you see on my weather map in the morning, the current temperature, that's coming from this weather station that we have at Camp Mabry. So that kind of covers everything that we've got down here at the ground as far as weather, where we live, where we breathe. Up above,
this one's my favorite.
Yeah, weather balloons. And this is something that I think a lot of us probably have a general idea of how it works, but it's really, really neat to think that this happens every single day. So basically, our friends at the Weather Service, they're pretty much in charge of all of the official recording of weather. Our friends at the Weather Service, before these became automated, have these balloons. And I will show you one of these balloons now because it's not just your normal birthday party balloon. This is a very big balloon.
It is huge.
Very big balloon, and it's a little lighter. It's not quite as thick as a birthday party balloon because they want it light. They want this to be able to
go all the way
thousands
up.
of feet in the sky. So this would be an old weather balloon at the bottom. They fill this with, usually it's kind of a mix of hydrogen and helium. Not just regular air because they obviously want it to float.
And do they have like a special pump for that, or?
Yeah, they would pump this full of that gas, and it would obviously get much bigger. And then attached, let me grab my radio son, is my radio son here. And
Wow.
so this inside this styrofoam box is a thermometer to measure temperature. It will record dew points. It will record wind speed. It'll record wind direction. It'll record the pressure, the barometric pressure. And so what happens is, if we go back to the maps here, you'll notice that the balloon, this gal inflated, there's a string that comes from the bottom of that balloon to the orange parachute. That's really important for the end of this story. The parachute is in the middle, and then in her other hand, you see this white box of instruments. Now, these used to be pretty big. These used to be like shoebox size, and they've made them very small.
And where does that go? Does it go inside the balloon or just in your hand?
At the very bottom.
Oh,
so
okay.
Balloon, parachute, further down the string, this is attached to the very bottom.
Wow.
And so it has these little wireless, or these wires, which obviously would be wireless because it's not connected to anything here at the ground, but they transmit the data to the computers down here at the surface. So what happens is my balloon gets inflated. They tie the parachute midway. They tie this at the very bottom. She lets that balloon go, and this balloon will float thousands of feet up into the air. And while it's doing so, this little white box is talking to a computer
Collecting
down
data.
at the surface. Yeah, recording the data, showing me what the weather is here, between my head in pretty much the clouds, 100,000 feet up. So the weather balloons tell us what the weather is between the top of my head, and for simplification matters, what I tell the kids is the cloud. So weather stations, these are all down here at the surface. They don't move. My weather balloons will move from the top of my head to the clouds. Eventually, and this is a very old parachute. It's definitely seen some bitter days.
Wow, it's a little ripped up.
Eventually, once that balloon pops, and it pops because of the pressure, right? As you move further away from the surface, the pressure becomes lighter and lighter. And so the pressure inside the balloon pushes, and eventually the balloon pops. And so parachute comes out. This tied to the bottom of my parachute comes floating back down to the surface. And we can reuse these, or we can recycle these. And so what's important here is if you ever actually find one of these, it has the address of
where
National Weather Service on there, because a lot of people will see this floating on the ground and think bomb. They'll think something awful. But it says on here, it specifically writes on there, harmless weather instrument. And it gives you the website to where you can learn more about it. But
or return it if you find it.
Or return it if you find it. Yeah, I always tell the kids, if you find one of these, keep it, because I think it's pretty cool, right? And I mean, it's styrofoam. They make a lot of them. What's also interesting is we've got weather balloon sites, 900 worldwide.
Wow.
I think that from what I was researching, there's close to about 100 that the United States controls, and that's between the lower 48, some of the Caribbean, and Puerto Rico and such. But these weather balloons will go up twice a day, every single day, at around breakfast time and dinner time. So 00Z and 12Z, which more often than not is about 6 a.m. and 6 p.m. So they'll send these up twice a day, every day, get the data, and the data then we get put into the computer models, just like the data that we have at our weather observation sites. That too will get put into our computer models and spit out a forecast for the next day and the next day. But weather balloons, I think, are in a really important part of getting that upper air data, weather data that we need. The little caveat here, as I mentioned, now that it's 2025, a lot of these are automated. So the one that we use here in Central Texas that our National Weather Service office is in charge of is actually out in Del Rio. And it's an automated weather balloon station. So the machine will inflate the balloon, put the string on with the parachute, and tie this to it. And so it's a one-man machine that does it all on its own. You don't need human intervention for it. Whereas before, it used to be a human, inflating the balloon, tying the parachute, tying the box of instruments to the string, and letting it go. Now, these can go, miles up into the atmosphere. They can also travel several miles because it depends on what the winds are above, just like a balloon would float whatever wind it's on. Same thing as a weather balloon. It's interesting because the closest one, as I mentioned, is in Del Rio, which is not very close to Austin.
It's very far from us.
Yeah, but on significant severe weather days where we know there is going to be a great risk to property or life, we know that the atmosphere can do some bad things to us. They'll do special weather balloon launches, and some of those weather balloon launches will happen at St. Edward's University, which is right in downtown Austin.
Yeah.
So the students there will get to be a part of this process. But more often than not, these are happening 6 a.m., 6 p.m., give or take, depending on the time change. Sometimes it's 5 p.m. and 5 a.m. But
in Del Rio,
twice a day, every day, 365 days a year, these balloons will go up. And we will get that data as these little boxes. I mean, they're pretty small, this little styrofoam, so it's light enough to float, with a thermometer and the anemometer and everything to record the weather. That's how we'll get the information from above our heads.
Wow, that's interesting. And I didn't know that my favorite instrument did all that stuff. I just like the way that it looked and the concept of a balloon going up in the air.
Yeah, absolutely. You can see there the wind speed, direction, pressure, dew point, temperature. We get all of those variables as these balloons will signal back to the computers the data. Now, there's always going to be mishaps, if you will. Sometimes these will get stuck in a tree. Sometimes they'll get hit by a bird or something and we'll lose the data, but there's another one coming that night or the following morning. There's two a day. So it's not like we'll lose a ton of weather. Sometimes they'll do special ones right in front of a hurricane just to see, where the winds are. strongest and what the temperatures are inside some of those storms. So it's really valuable data to get. And I always think it's interesting to think that, less than a quarter of them are found and recycled. So you wonder, you're like, how many of these are just kind of laying around?
Or just floating around.
Outside in the field, yeah. I also was curious, and this kind of sparked the conversation this morning, I was reading online this week, there was a plane that unfortunately hit a weather balloon. And I was like, what? And it cracked the window of the cockpit.
Wow.
And it injured the pilot. He had like little shards of glass, little scratches
all over his arm. A commercial plane?
A commercial plane, yeah.
Wow.
I want to say it was a United plane it was going from Denver to LA.
How big are these weather balloons?
Well, that's what I said. I was like, what?
I can't imagine that.
But those planes are moving, 500 miles per hour. So maybe, but it kind of sounds like this was not Weather Service
or being
FAA,
used.
DOD. This was a private organization that sometimes those other companies will want data too of the upper air, of basically the upper atmosphere. And so they'll set off their own balloons. A while back, I don't know if you remember, Esme, we had one last week and a few weeks before where people sent in pictures of what kind of looks like a jellyfish.
Yeah, I remember that.
In the sky. Yeah, and that was a weather balloon, but a private company weather balloon. So you usually have to get that cleared by the FAA before you just start launching things into the sky.
I know. Are they really the same level as the planes?
They can sometimes
go up that high?
I mean, 100,000 feet. Planes are usually up high. I think this must have been like a takeoff or coming in situation.
Or accidentally just kept going.
Yeah. Because usually I would think, I mean, who knows though? So sometimes these weather balloons are found miles and miles from the launch site. And you think, well, this quite the journey, right? And you can, if as long as that GPS trigger is still there, you can track where it goes, which is really interesting too. But
poor pilot.
I know. Everybody was okay, but I just thought that was really interesting, knowing I was going to talk about this today on Kristen's Classroom. That a weather balloon, unfortunately, got in the way of a
pilot. That's scary.
Of a plane. And then something else I wanted to mention too is satellites, the importance of satellites. We've got a whole fleet. The United States has a whole fleet up there. There's kind of four main geostationary satellites that we use and two polar satellites.
Is one in New Braunfels?
The satellites are up in outer space. So these are up in outer space, and basically they're taking pictures of the Earth, and we can do it every 5 minutes. If there's severe weather, we can get a picture of Earth every 30 seconds.
Wow.
Which I know, I think is crazy, because we always joke about the fact that, unfortunately when somebody robs a bank or something, the red light cameras, you get these like super fuzzy, grainy photos.
And these satellites have better photos?
These satellites have picture perfect, like super clear images of Earth, and this is 22,000 miles off the surface. We're getting beautiful pictures of Earth. So
be careful out there. Don't do anything wrong.
I know. We should be using these weather satellites to take pictures of things. No, but it's interesting because during hurricane season, obviously, these are crucial. Satellites are pretty much one of our first tools we use to identify areas that could potentially give us tropical systems later on down the road, or hurricanes, because we don't have weather balloons going up.
No, we don't.
Most of the ocean. The exception to that would be the Navy. Sometimes the Navy on their ships will send up weather balloons for the Weather Service, but also the weather stations. We don't have these all over the ocean. So the satellites that are hovering above the poles or above the equator as the Earth spins will take pictures and will show us where these clusters of storms and showers are. So that is always very important for us. So,
and how often do you grab a picture from one of these satellites?
Every 5 minutes are uploaded online. And that's the thing, is most of this data you could find if you Google it. The weather station, the one down here at the surface, that's on the National Weather Service website, National Weather Service Austin. The weather balloon data is a little bit harder to find, but it's on there too. And then the weather satellite data is online. I'm sure if you just Google it, GOES satellite imagery, you'll be able to find it. But all of this data is available to the public. But what's important for us is, yes, we can look at the different, what is my weather station showing? What is my weather balloon showing? What is the satellite showing? But that data gets poured into the computer models.
Mhm.
They do all that math, the physics that our atmosphere works by, and then we show the data, the output on TV. Those maps that show, hey, there could be some rain on Friday and the cold front coming in. That's using data from weather balloons, from weather stations, from satellites that we have. Yeah.
Those are the three main instruments that are used to forecast a 7-day forecast or maybe like a November outlook.
These are the three main tools that we get data from, and that data gets poured into the computer models, and the computer models are what we use to make the 7-day, to find out the forecast high temperatures. There's one other thing I'll kind of mention here, because this was also something we highlighted last week in Kristen's classroom, and you asked about New Braunfels, the radar.
That's what I was thinking of.
Yep, radar is a tool we use that tells us what is happening right now. So radar will never show you what's happening in the future.
Mhm.
It's always going to show you what's happening right now or over the past few hours. And so basically you can think of a radar as it sending out a little beam of energy and waiting for that little beam to hit something to come back to the radar. And it's transmitting a lot of energy in that beam, 750,000 watts.
Wow.
And you think of that, the average light bulb is about 75 watts. So it's a lot of energy being sent out. That beam of energy is waiting to hit something, but it gets shot out into the sky, right? So we don't want it hitting trees or cars and stop that little energy, because it would give us bad data. We want that beam of energy to hit a hailstone or a raindrop sometimes, to come back and hit a bird. It's not like it actually hits or hurts anything, but it's that scattering or reflection of energy that comes back to the radar. And we can set the radar to scan at different levels. We can do it to where there's different modes where we want to see it super sensitive or not so super sensitive. I think what surprises a lot of people is those radars, those big old golf ball like domes that you see sometimes. It sends out that beam of energy, that signal, 7 seconds, and then it spends the entire hour spinning around waiting for that beam of energy to hit something, scatter and reflect, and come back to the Doppler. So most of the time, as that Doppler spins around, it's just listening. It's looking for something to come back to it, that little beam of energy to come back to it and say, oh, okay, using the math we know, if it took this long to come back to the radar, that little beam of energy, and we got this much back, that means that there is probably a hailstone this big, or there's probably a raindrop this big. And it tells us all sorts of different things. I mean, not only the type of precipitation we can now look at, because before, a couple decades ago, radar only scanned one way. It only scanned in the horizontal. Now radars will scan horizontal and vertical, so we get an idea of the shape of whatever that radar beam is hitting. So it detects hailstones, precipitation. It'll show us which way storms are moving, which direction tornadoes are moving. It can estimate the amount of rainfall by looking at how much moisture is in the air. We'll get some real-time scans sometimes. I mean, sometimes it's only a couple-minute delay as far as those scans go. But we'll come back to this, because these are the list of radars that we use here in Austin, but I think it's a little easier to see on the map.
Yeah. Let me make that bigger.
Yeah, there's a few that we use. Now, KEWX is the main one. That's the one in New Braunfels.
Mm-hmm.
The Granger radar is up in Williamson County, KGRK. We can also use the Del Rio radar, the KDFX, and then sometimes even the Corpus Christi radar, KCRP. These are all the ones that our local office uses, because this is the local office's coverage area. Here at KXAN,
we use the Williamson County.
we use the Williamson County one and the EWX. The orange color basically is how far the KXAN signal goes. So we're most concerned there. GRK, EWX, and that's what you see here. That little radar beam of GRK is up in northern Williamson County at Granger. And then you see there the one spinning. This is your real-time radar. This is that radar beam, that radar spinning around, trying to look for any sort of reflection, any sort of beam coming back to it. That obviously with no rain, we're not going to see anything. But that's the indication, the visual of the radar listening for some of the energy to get scattered back to it to identify raindrops or
tornadoes,
or snowflakes or tornadoes or hailstones, any kind of precipitation really. So that's that's kind of a radar crash course, if you will. Sends out a beam, waits for it to come back, depending on what it hits, if it's a raindrop, hailstone, anything like that. We can also evaluate the winds, right? That's how we identify tornadoes. But that would be kind of those three: the weather station, the weather balloon, and the satellite collect the data. Radar shows me data. It shows me where things are.
Real-time stuff. And what about buoys? I've seen those in the ocean a lot, and I'm not really sure what they're actually for. There's a lot of reasons for them, but is there a reason for weather?
Yep, for sure. There's buoys put in special places to give us data. So wave height would be a big one that we're concerned about. There's also temperature, wind speed. Those are important, especially when a tropical system makes landfall. We're looking at the ocean buoy data. A lot of the times, mainly for wind. We know the waves are going to be big, but we want to know how strong are those winds getting. So certain buoy networks will show us and have those weather instruments on them. Sometimes there's even sensors. We've talked about this before too on Kristen's classroom. Sensors at the bottom of the ocean that measure pretty much the weight of the water, and it tells us how much mass, basically a tsunami tracker, how much mass would be over that sensor to give us an idea if there's any tsunami waves coming forward.
And which one of these is the one specifically that meteorologists?
I mean, they could look like any of them.
Anything? So even these like circular ones?
If you not like swimming hole buoys,
something like
they
this.
would be a little bit taller. Yeah. So if you look at there's a couple over, it says meteorology on it.
This one.
Yeah. So it would have, you see at the very top, there's a couple weather instruments there.
Let's see if I can make it bigger. Oh, I think that's the biggest it gets.
It would be hard to detect if you weren't looking for it. But you would have likely an anemometer on there, a wind vane on there, a thermometer to measure temperature and such. And not only temperature of the air, but there's also usually a temperature underneath to measure the water temperature. So ocean buoys would be another way to get that data. Aircrafts sometimes have weather instruments on them. More often than not, that happens, especially here, the San Antonio International Airport. That aircraft data gets sent to the National Weather Service, and then we can kind of poke them and prod them for that. But that usually isn't for the public, the aircraft data.
That's awesome that you use all these instruments.
Yeah.
So we all know exactly what goes into forecasting the weather, what instruments you all use, who you reach out to, where you get that data from. That's very interesting. And thank you for bringing all this stuff in so we could see it in person.
Yeah, absolutely. It's fun to show the kids, especially the weather balloon, because they think birthday party balloon, right? So to know that the weather balloons, and sometimes those weather balloons, by the time the pressure on that balloon is enough to overcome the pressure outside of it, sometimes those can expand to be the size of about a car. They can get real big.
And
way
that's
up
why
in the atmosphere.
That poor pilot got it into his
I know.
window.
I have to do some more research about that, because it did surprise me. I thought, a weather balloon, But the crazier thing, I mean, it's crazy enough to make the news, right? We know this doesn't happen all the time.
Yeah.
But I have a feeling that it was not one of these, but probably one of those private company weather balloons that had a little bit more beef to it on the bottom.
Yeah. Well, hopefully they stick to using the correct material that these use, because it's safer, right?
Yeah, and the weather, like I said, a lot of what we do with data and weather observation and weather collection is a partnership with Weather Service, NOAA. I mean, the satellites would be NOAA and NASA. The weather observation sites would be the Department of Defense, Weather Service, and the FAA. So there's a lot of fingers kind of involved
regulation.
In there. Which we want when we're talking about observing data, and it could potentially have weather affects anything and everything we do. So anybody who needs that data would be able to find that online.
That's awesome. Well, you can also find online Kristen's article on all of the weather instruments that we just talked about. Kristen, anything in here that we didn't mention?
It's just a more in-depth look at what these measure. I did go a little bit more in-depth on the satellites, the polar satellites and the geostationary satellites that we have. So if you're interested in that, you can scroll all the way down and find that. But I think we covered it.
Yeah, and we have some extra graphics and photos in case you want to show your kiddos or your kiddos' friends.
Yeah, absolutely. And like I said, a lot of what we do here at Kristen's Classroom is kind of aimed at kids. And so if it seems like, well, that seems very simple or watered down, that's the point, right?
Yeah.
Because we know meteorology is a very complex issue. We can go into all sorts of different things about how a radio song gives us a sounding, and that's pretty much a slice of the atmosphere. And we could go there if we wanted, but this is mainly designed for getting kids a little bit more involved in, studying weather with things that make a little bit more sense
and look a little cuter.
Yeah, exactly.
Is there anything you would like to share from your school visits this week?
Yeah, absolutely. I had a couple that I went to just yesterday. I went to Rutledge Elementary.
Ooh, that's a big group.
Yeah, 4th and 5th graders. There were close to about 300 students there. So it was a good time. This is their principal and one of their educators there. Miss Duffy, I believe, was Educator of the Year a couple years back when she was with Round Rock ISD. But Rutledge Elementary is now at Leander ISD. And so we talked about different cloud types, different types of weather. And then I did something real fun last Friday that I actually haven't done before. Dripping Springs Elementary, they do morning announcements and they do Friday assemblies. And this group is in charge of both of those. And their instructor had me come out and give them some tips and tricks of speaking in public.
Aww.
And so I thought, I've never done that before, but I thought this is something obviously that I do every single day, whether or not it's in front of a group where eyeballs are staring back at me, or a camera where I know there's eyeballs on the other side. And I had some of my coworkers, the morning team and the evening team, give me what their tips were as to public speaking. And a lot of them kind of followed the same theme of, we don't have news voices. We talk like we do in person. This voice is what you're going to hear me say at the grocery store and on TV. We talked about the fact that you want to talk to people at home like you're talking to a friend. Don't use words that you normally don't use, right? Don't say things that you normally wouldn't say. You want to be talking to the audience like you're talking to a friend or your grandma or your mom, something like that. And then just breathing, slowing down, enunciating, those kind of things that as meteorologists, as anchors, as reporters, that we practice before we get up on TV to make sure our message is coming across as effectively as possible.
Yes, practice makes perfect. And I think this is a great skill for these kiddos to start learning at this age, right?
Yeah, absolutely. It's a lot of inflection and tone and energy that we were talking about. But I told them the fact that you're in elementary school and already able to get up in front of a group
and
of your
speak.
peers and speak, I think is huge. I mean, that takes a lot of courage. And that's something that I really pressed on them, is you're already doing more than what a lot of people could ever do. So find even more strength in that, find even more confidence in that you're being able to take that step that's really scary for a lot of people.
And continue that journey, because it can take you so far, right?
Yeah, absolutely. Whether or not you go into news or you're, at a company and you need to make a presentation.
Any position would need that.
Yeah, a lot of times you need those skills. It's, not only people's skills to be able to read the room, but also to be able to communicate in a clear and effective way. And sometimes it starts as early as 4th and 5th grade.
Yeah, that's awesome. Well, the best of luck to these kiddos. And we can't wait to see what you learn from these kids next week at your next visit.
Yep, I got a couple more on the docket, so I'm sure we'll bring back more stories next Wednesday.
Well, thank you, Kristen, and we'll see you next week.
Of course, see you then.